Welcome to HP Tuner's GM Gen 5 training part 38. In this training module, we're going to take a look at how we can perform a rescale to the zones or boundaries in our dynamic virtual volumetric efficiency relationship. So if we're going from a naturally aspirated engine to a forced induction on that same engine, we need to go and rescale these zones so that we have more accurate fuel delivery and resolution in our boosted areas of operation. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at understanding our dynamic airflow zone operation and how it relates to our virtual volumetric efficiency table and ultimately how that relates into our speed density coefficients. We need to make sure that our dynamic airflow has proper zone ranges so that if we're going from a naturally aspirated engine, we're adding on a supercharger or a turbocharger, we're giving more usable resolution range in our speed density coefficients so that we're able to characterize our fuel delivery better for that force induction application. So we need to modify our zones so that they're laying out across our virtual volumetric efficiency better to give us more tunability out of our table and ultimately better fueling and more precise fueling delivery. So we're going to take a look at how the zones work here in this tutorial, and then we're going to take a look at how we can modify the zones so that they're allowing us to characterize our boost operation. It's actually pretty straightforward. Let's dig in here and let's take a look at what this actually means, because as I'm talking about this, you may have no idea what I'm talking about. So first things first, I have my 2018 Yukon Denali calibration file. This is an L86 engine. This is a naturally aspirated engine, and I will plan on going force induction with this and adding on a Magnuson supercharger kit. So I'm going to have to go and prepare my zones so that I'm able to have better fueling and better characterization as I get into boost. As my P ratio goes above 1.0, the P ratio is what we find in our virtual volumetric efficiency table. So let's talk about this real quick here. So I'm going to jump into the calibration file. I'm going to go here to engine, and under engine, we're going to go in from general over to airflow, and airflow here, we're going to move into our dynamic tab. Now here under our dynamic tab, we're going to find that we have all of our dynamic airflow parameters. We're going to find that we have these things called zones. So there's zone boundaries. There's a P ratio boundary. There's an RPM boundary. We find our P ratio boundaries, displacement on demand. We do find some hysteresis functionality in here. And then down here we have prediction coefficients. We're not going to be editing the prediction coefficients. Those are for the predictive behavior of what the engine control module is going to try to predict the dynamic movement in our dynamic airflow is going to do. So trying to predict ahead of how airflow is going to move. We're not going to edit anything in there. What we're interested in specifically is editing our zone, RPM zone boundaries and our P ratio boundaries. These two are of interest. Now, the way this is going to work, dynamic airflow, we've touched on this already, it's going to be taking a look at if we're in this case, there's a high RPM disable, so below 4,000. If we're below 4,000, we're going to be in a hybrid mode between mass airflow and our speed density volumetric efficiency airflow. So we have two airflow models going on at the same time. Steady state conditions, the engine control module is going to weigh more heavily on that mass airflow. That measures steady state airflow really, really well and really accurate. But if we get into a transient condition, having a large throttle change, a huge airflow burst, we'll find the mass airflow sensor is a little bit too slow to react. And that's where we need to rely on the speed density volumetric efficiency type of airflow registration. So at any given time, the dynamic airflow can translate and move between mass airflow and our speed density volumetric efficiency airflow. And we'll look at this and talk about this further in future tutorials here when we're going in and dialing some things in specific for airflow models. But it has the ability to switch between one or the other, or it can have a weighting factor depending on where we're at, which is all part of our parameters here under dynamic airflow. Now the takeaway here is that we have the dynamic airflow using and looking at the speed density here based on these different boundary ranges. There's zone ranges. So speed density, we have our speed density coefficients. This makes up the estimated air mass coming into the engine. We discussed this already in previous tutorials. So the dynamic is looking at these different zone ranges and then looking at the VE coefficients to figure out what it should reference in terms of that airflow or air mass in the speed density calculation.
So this still might be a little bit confusing.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.